So thanks everybody for being here, and thanks Susan for that wonderful introduction. So I'm Dana Wolff-Hughes. I am a program director in the Risk Factor Assessment Branch at the National Cancer Institute, and I've been working with Wendy for quite some time on smart and connected health. And we're really excited to talk to you today about the program and really start off with sort of giving you a general overview. And I think after this, we'll then have some presentations from PIs.
And I do want to say, I see you taking pictures of the slides. The slides are online, so you got them all. So don't worry, just relax and enjoy. Our team keeps changing, but you can see we have a very big team in NSF. We have in Smart Health, we have SISE, which is Computer and Information Science and Engineering, who leads the initiative, but we also have 2 divisions in engineering that are a part of it. We have Math and Physical Sciences, that's the data sets, the statistics and math program, as well as social and behavioral and economic science. So we have them throughout the foundation helping us on this initiative.
And this is a short list of those on the NIH side that are involved in Smart Connected Health. Currently, there are 21 institutes, centers, and offices that participate. The Office of Data Science Strategy with Fanglu and Susan, they lead this on the NIH side. But we have tons of partners representing all different types of institutes and centers. For the priorities, as Susan mentioned earlier, really does vary across the institutes and centers. And so for the solicitation on the NIH side, there is a notice that I would highly encourage you all to look at that has the specific priorities for smart and connected health for each institute, center, and office. And the program itself is focused now on smart health and biomedical research in the era of AI and advanced data science. This is really a cross-cutting transdisciplinary program. It's of course supported by both NSF and NIH, and has been going on since 2014, I think now.
We've been partners since 2014.
Yes, and the slide needs to be updated. The next proposals are actually due in November of this year at 5 p.m. But the program itself, they're really focused on integrative projects, bridging 2 or more disciplines, up to $1.2 million in total costs of up to 4 years, so about $300,000 in total cost per year. Really focused on interdisciplinary teams and, of course, fundamental science and technology issues.
So when we developed Smart Health, this was really, Smart Health was initiated from the NIH side originally, because what we saw was when we would go to NSF, we would see science we wouldn't see coming over to NIH. So the goal was to create a bridge that we could do this, but it really is based on Pastor's quadrant. So if anybody's read Don Stokes' book, you know, if you think about NSF, you think about Niels Bohr. You know, fundamental physics, right? We do a lot of very, very important fundamental science that are totally theoretical. We still do that. But if you think about Louis Pasteur and the work he did in microbiology early on, he was doing fundamental science, but he had a problem he wanted to solve. And so Smart Health is really about that quadrant, right? That we want to use, we want to grow fundamental science, but it also has an application that's a really important area. So we are not Steve Jobs at NSF. We do not, that's applying science to a problem. So Steve Jobs did a great job of actually taking a lot of the science that had been funded by other agencies and integrating it, which is really, really important. But it's not what we're looking to do here. We're not taking existing sciences and putting them together. What we're trying to do is develop new science. And nobody wants to be the low quadrant where there's nothing new and it has no application. So, am I doing this one? Yes. Yep. Okay. Our goal on this, this is what this initiative really tries to do, is to bridge the gap in the scientific areas. NSF has lots and lots of science that has a health component, a biomedical component. That won't be a surprise to many of you, I hope. We have bioinformatics programs that run out of the biology division. We have bioinformatics that run out of SISE. We have bioengineering that comes out of engineering. So we have a lot of work that crosses these areas. But we really wanted to be very explicit in smart health and bring together, we wanted to advance multiple areas of science, but we wanted to do it very, very explicitly in smart health. So you can see what we're trying to do is we're bringing together all sorts of the fundamental science areas, which are the NSF sciences. So think about the NSF sciences, but really do them in the NSF and the NIH mission area. So you can advance your algorithms, you can advance the way you're doing your science, but you can do it in an application area, and that's what we're really looking to do. So with us, with this initiative, our goal is really to have people come in and say, I say when people write a proposal, they start with the big topic, which is usually it's a health topic, right? So this many people die of this a year, but they die of this because we don't understand either the trajectory, the models, the whatever it is, right? The mechanisms, whatever it is. And we can't do that now until we have a new scientific understanding of the fundamental processes here. So they have to do the research gap. So they start there, and then the science is really based on, am I advancing that? Now, health is important. Health, biomedical problems, whatever you're doing in there has to be important, and you have to have a right team member for that. One of the reasons we started this from the NSF side was they saw projects that were health related but had nothing. They were not based on cutting edge science. I can't tell you how many times I see proposals come in and they're solving a problem that NIH has already funded. We know how to do it, but it doesn't happen in practice. So my computing world is not seeing that happen in practice. So what we try to do now is make sure that the right people are on the team so we can have the cutting edge computing, engineering, mathematics, statistics, social behavioral engineering, but also that we have the right people from the biomedical side so that we're not repeating and doing something that's already been done, or we're not solving the right problem, right? You can do really amazing analyses with Twitter, but it's probably not going to solve the suicide problem, right? So, which was one of the ones that I perpetually see, by the way. And again, it has to be the right team. Now, the important thing is these are not duplications of projects that would already exist. So if they're already happening at NIH, NSF, AHRQ, VA, we know there's overlap in here, but with this one, we're really focusing on the fundamental science questions. So remember that this is the next solicitation comes in November. It's November 10th of this year. 10th of this year. But then that will be the last round on this solicitation. So we will likely have new themes. We always try to update our themes as we look at the scientific portfolio of what we've got. But you can see we have many, many, many different ideas, and Dana's going to talk about some of these, but we're also looking for your ideas. So the themes are really a way to get people thinking about these problems, but also we know in the community that you all have really interesting ideas. And bring those ideas to us, bring them here, and so let us think about them. And you will, when you hear our speakers talk, you will see there's a real diversity of ideas that came in under these ideas. So, Dana?
Yeah. So, and just as Wendy said, your idea can fit in the middle, and these ideas and themes are not mutually exclusive. So we see a lot of times applications come in where they're hitting on maybe a couple of these themes. So for example, somebody's coming in and they're proposing a novel multimodal sensor system that's really focused on automating health, or maybe it also has a usability component. But these themes in and of themselves are really important and do focus on the fundamental science. So with novel multimodal sensor systems, making sure that we have devices that are not just measuring one thing, that are innovative and not just another accelerometer, for example, in my world. Also usability. So are the devices that are being created, the AI models, other applications actually usable to different communities for which they're being sort of taken and translated to? What are the novel needs there to make them more usable? Automating health is another big one on the healthcare side in particular, where we see a lot of times we want to go paperless, we want to be automating things, but those actual applications that are developed don't actually translate and aren't working to scale. Wendy, do you want to take the rest?
Sure. And so there's an interest too in medical imaging. We do a lot of work in computer vision and image analysis, but we also want to understand, what about the users of this data? How do they understand that data? Because we know that, when you get this data, what do you think about it? How do you interpret it? So we're really trying to understand that. When we think about disparities come up all over the place. In AI, we talk about fairness all the time. Because you have to talk about fairness. There's issues in there all the time. But can we use some of our new analytic models? Can we build new science around understanding this and unpacking this? So, of course, AI is a big part of this, but it isn't just create new deep learning models, create new ML. It's really understanding it in a fundamentally, it being embraced in the application area, but also doing this really exciting science. And I think what really makes smart health exciting to me is because it builds these teams that, you will create students that speak 2 languages. I remember the first time we ever did a workshop in this area, 2011 at NIH. There was a whole brawl between, I was leading it from the NIH side, and the PI that was running it said, we need ground truth. And I said, ground truth? What the heck is ground truth? And I said, you mean the gold standard? And we went through this. We had no idea what we were talking about. Neither one of us had a clue what the other one was talking about. So, we're building those languages. We're building this understanding. We're building this in a way that we can start to answer the right questions and be able to do the right problems. So we have, in addition, NSF and NIH partner on this, but we have the standard NSF criteria, intellectual merit and broader impacts, and we'll talk about that in a little bit. But on smart health, we also have a scientific requirement. We're looking for multiple sciences in here. So it's not just NIH and NSF science, but we really want to cross boundaries. So often there's an engineering component in there. There might be multiple areas of computing that come together. There might be, when I think about image analysis and interpretation, we have a social behavioral component to our computer vision work. So we bring together multiple areas of science. The other thing we do is we want a collaboration management plan. So we really want people to write out and specify, how are we doing these partnerships? I can't tell you how many times I read things that say, they're just down the hall. That's basically what they write. I'm just down the hall from these people, so it'll work. Just down the hall doesn't make a partnership. And these are hard. Doing these projects is hard because it pushes us in ways we haven't been. And then we need an evaluation plan to really look at this. So again, like I said, with the 2 hours areas of science, we think about, they can come out of the same main area, but we really want not just, I'm just advancing one small area, but across these boundaries, because we think that the health issues and biomedical issues really do cross everything. So, these aren't limited to, but there's all sorts of things. Whenever we do any of the natural language processing, we end up with perception and cognition. Emotion often comes into these things. There's all sorts of things. Computer architecture is in some of these projects. We're really just crossing the boundaries on this. Is this one yours?
Yeah. So as Wendy said, these applications come into NSF, so they're sort of written in the NSF style, and they require sort of specific things. One of them is the collaboration plan. And that plan is included as a supplementary document. It has to be no more than 2 pages. But in that, you must describe the team and their roles and ways to integrate the members and support collaboration, as well as listing each individual team member's expertise for the project. A lot of times what we see with these, though, is that somebody will ask, well, do I need to have a doctor as a part of my team? Do I need to have a clinician? And we really don't sort of say it needs to be somebody in a specific area. It really needs to be the best person for what the specific research is that you're proposing. So it could be a clinician, it could be somebody else, and it really just varies. But the goal is to make sure that you're building the right team of people to answer the research questions and conduct the project. You also need to have an evaluation component, and this component can target multiple areas. So technical functioning, the validity and reliability of either the software or hardware or the model that you're building, the usability, and the impact on biomedical and health outcomes. These proposals, though, should not be focused on randomized clinical trials. Given the new change in the NIH definition for clinical trials, most things may have an aim that ends up being a clinical trial. That's not what we're talking about here in terms of randomized clinical trials. We're talking about the large sort of like cohort studies with large N's. That's really not within the scope of smart and connected health proposals.
So when you're thinking about it, if you're thinking about applying, first off, you should talk to us. We really do like to talk to you. Your NIH folks will talk to you. Your NSF folks will talk to you. If you don't walk out of here with one thing, talk to your program officer. We really do want you to have that focus. You want to have the focus. You want to have a really solid application area. And one thing we haven't said, but I think it's implied, and I think we'd be remiss to not say it. The goal of this project is to cross bridges here. So we would hope with Smart Health, I assume these are prototypes, these are early stage projects, that if you have the right team, that you set them up, whether you get funded by NSF or NIH, it sets you up for an NIH proposal next. So you should be able to do something really cool in your Smart Health. It's really innovative, it's risky, and then you get enough data to be able to do an NIH proposal next, where you can really test, is this doing what I think it's doing? Because you're not going to, at 1.2 million with total cost, you're not going to get enough to run this all the way through to validate what you want. But you're going to get that data that's going to put you in a position, and you're going to have the right team to be in position to write that proposal. We really don't want these, you don't want to apply existing sciences. I can't tell you how many messages they say, we're going to use machine learning to analyze this data. Okay, tell me what's new about your machine learning. Well, we're going to use a Markov decision model. Okay, tell me what's new. So we need the new science. We need to think about that. And you need to write, this is not a proposal you should be afraid of your algorithms. Write them. You'll see, we have a sample, we're going to do a mock review in a minute. You'll see they are technical. These are technical proposals. And the panel is geared toward being able to really understand what these technical proposals are. You're going to have about 2/3 NSF people and a third, or 3/4 NSF and 1/4 NIH on there. And the NIH folks aren't afraid of algorithms either. There are a wide range of folks that have experience in this area. So we really want you to have that fundamental science in there nested in a really great application. And if you think about this, don't have this as a topic that fits in another. If you've got a VA topic with VA data, you're probably good going to VA. You really want to think about, is this going to be the right project for this? So don't come in and say, I'm going to do machine learning. What's new? Don't come in and say, in our clinic, all they do is get blood tests and give a report back. Patients don't know what their data means. Well, that's true in most clinics, but it doesn't mean we don't have better science than that now. So you really want to think about how do we do this? So what about COVID? I hate talking about COVID. I think we're all done with COVID, although we're not done with COVID. So don't think I'm saying that. But people, if you wanted to come in with something on COVID, you really have to think, do we have 4 years left to think about this? Is it, if you're trying to do an epidemiological project using something, doing some kind of new analytics approach to this new data fusion, new data integration approach, is there really going to be enough in a 4-year project for that? NSF has been funding stuff on COVID since COVID began, since very early in COVID. NIH has done the same. So it's just, when we don't think about, if you think about, well, is COVID going to limit the project? You talk about that in your proposal. COVID limited everything. We all made it work, and I'm still getting reports that I'm exceedingly proud of in Smart Health. So, I think COVID is just something we need to work through. We need to talk about it. We need to do the appropriate things. So, you want?
Sure.
Okay, you do this.
Yep. So for your proposal, I think because this is both done on the NIH and NSF side as a partnership, but applications are submitted to NSF, we recommend that you start with sending a one-page summary to NSF at the email here, so sdh-correspondence@nsf.gov. And that sort of summary should describe sort of your project, the merit, and the broader impacts. And what will happen is that either Wendy or one of her lovely colleagues will monitor that inbox and will respond back to you based off of what you've submitted, either by email or maybe trying to set up a brief call to discuss further what you've submitted. And then usually what happens from there is there's also a connection with NIH and the NIH program officer. And so at that point, the NIH program officer will also connect with you to talk about whether or not your application sort of fits in and how it can be tailored on the health side. And this has really worked well. We've seen a lot of success with PIs coming in, especially those who are traditionally familiar with submitting to NIH as their primary funding institution. There's a lot of differences compared to the NIH application. And so starting with NSF, I think, is the best place. And also, if you were to contact your program officer, in a lot of cases, what Fenglu and I have told the NIH colleagues is to just go ahead and have the PIs start at NSF. So you may just get directed to them anyways. And then from there to apply, all these applications come into NSF. The link here is to the solicitation, which Wendy said the next application due date is November 10th of this year. The NIH notice, which has those IC specific topical areas. And what you need to know is that once those applications come into NSF, they're also reviewed at NSF with the presence of an NIH scientific review officer, which we'll talk about more sort of in the mock review and panel. And then at the end, once review occurs, there's a process by which NIH selects applications to come over. And it's at that step that you may be asked to submit your application into the NIH form. And that's why it's really important from the get-go to focus on the NSF side, because that's where the submission and the review occurs.
And it's important to know that since this is NIH and NSF are looking for the same science here. So we're really looking for fundamental advances. So if it doesn't do well in an NSF review panel, it's not going to get picked up by NIH. If you have a project for NIH, it should be submitted directly. So this one, it's really important to think about the NSF criteria on this, because that's where projects do well. If you're looking, all our awards are listed on our website. You can find all our information. As you can see, I love this one because it was upping the odds for kidney donations using game theory. Great projects done for kidney transplants, and we've done them in Smart Health too. But I think, there's a lot of information on this. And remember, if we're going to make these advances, I think this is a relay race. You have a fundamental question, you partner with somebody who's in the application area, and then you hand back and forth, because you can't get it over the finish line. When I first started this, I had computing and engineering people saying, how the heck am I going to give 10 years of my life to get to this project to the end? To get it to FDA or get it to whatever it needs to be. And it's like, no, you have to have the right team, because one person alone can't do this. So we really want people to be able to have the right teams that can take these projects as far as they can go. So with that, we'll say thank you. And we're going to do, and Fenglu will introduce it, but we're going to do a brief review of a proposal so that you can understand what we're looking at. So Fenglu, you want to?